Welcome to this virtual session of the LAYER123 World Congress, where I will be discussing why testing matters for the delivery of software-defined networking, better known as SDN, products. My name is Beth Cohen, and I am a software-defined networking product strategist for Verizon. I work on creating and developing some of the most advanced networking products in the market today, including development of several SDN products and services, including virtual network services and secure cloud interconnect. As the software-defined networking becomes more mainstream, operators have found it is not enough to just convert everything to software and step back and expect it all to work. This is where testing can make all the difference in the world. During this session, I'm going to touch on some of what we learned during the development of our SDN product portfolio. First, I will look at some of the fundamental issues that triggered our rethinking of how to best ensure that solutions worked as expected in production network environments. I will then talk about what Verizon did to address the concerns by building a test platform and environment that allowed us to test all the vendor systems as they have been integrated into all the systems and networks that Verizon owns. So we built a comprehensive end-to-end test platform that allowed us to really understand in great detail how these systems work together in an integrated environment. Finally, to put it all into context, I will review how the investment into this test environment has benefited Verizon and its vendors and its customers. So let's dig into the problem statement first. As Verizon was developing and launching the SDN portfolio, it quickly became apparent that there was sometimes a mismatch with how network applications were actually performing in the field under production conditions and how they performed in the lab under what we found were often conditions that did not match production. Often the vendors had created lab performance numbers that didn't quite match with what we were seeing in the field. So we needed to dig into those issues in more detail. Some of the issues we encountered were often feature sets and configurations. Specific feature sets would often have significant effects on the throughput in the field. For example, in one situation, customer was turning on encryption throughout, which caused the throughput to drop significantly due to the processing of the encryption, which all of this led to unpredictable behavior in the field. Often when you service chains these applications together, it's not always possible to figure out exactly what is going on, where the fault is, and who is to blame. So one of the things that we are able to do in the lab is to really pick those types of things apart. We also discovered, of course, that vendor performance reports just commonly differed from what was in the real world. They were often done in labs that were under the best or ideal conditions. So we ended up not being able to rely on them as various features were turned on or turned off. And again, this led to unexpected results. Another thing we often saw was a dramatic variation in vendors' capability to fully take advantage of the virtualized environments themselves. So what we saw was vendors would wildly vary in how well they had converted what were originally appliance-based physical applications into virtual applications. So as you're probably aware, SDN virtualization is not a fully mature technology with few standards and even fewer reference architectures to guide the vendors. What that meant is that we often saw wild variations ranging from very simple virtualizations where the vendor had not taken into consideration any optimization of the underlying environment in the cloud to thoroughly developed and optimized virtualized network applications, and pretty much everything in between. So now that we've identified the problem, Verizon's development engineering team decided the best way to address these issues was to build a lab environment that that not only would allow us to troubleshoot customer issues, but also allow us to drive development of new features and capabilities back into the product itself. To reduce Verizon's risk and provide better service to our customers, Verizon has built an entire performance testing lab environment. The test bed that we've built is part of the production network, which means that we can test the integrated service chains in real-life environments. Not only is the lab able to use actual traffic loads, but it has the capability to reproduce traffic conditions and loads where issues were reported. So we are able to duplicate the conditions for troubleshooting and determining resolutions. The test lab also includes a suite of automated test frameworks and procedures for testing the integrated service chains. All the test suites are based on standards and benchmarks for testing network performance, which is of great value to our customers who can take advantage of Verizon's ability to work across our portfolio of vendors and make sure the integrations work as they're supposed to. As a large operator, we have the capability to work with all the vendors involved and allow them to work together to make sure these integrated service chains work as we launch new services. The good news is the lab is used for both product development and production support, which allows for a really truly net DevOps type of mindset that makes sure the issues uncovered in production by the production customers can be folded back into the development efforts as we add new features and vendors to the portfolio. So it's a 360 revolving continuous involvement evolution. So let's take a minute to delve a bit deeper into how the lab can be used to improve not only Verizon's offerings, but also provide feedback to our vendors and our development teams so they can improve their products as well. Some of the lessons we have learned since we built the lab include we can now verify all vendor performance claims. Since these products are sold to our customers as integrated packages, it is imperative we validate these claims. Our reputation is on the line and customers expect it. We thoroughly test all integrated service chains such as security and SD-WAN or routing and WAN optimization, just to name two examples, in collaboration with our vendors. Since specific features can have an outside impact on network performance, we now ask all our customers during the sales process about how they're planning to use the services to minimize the possibility of them experiencing unpleasant surprises during deployment and production. One example is we ask customers for their use of voice over IP and encryption on the security services, since they have an outside impact on performance. So let me apply what the testing lab can do to a situation we encountered in the field. A large financial institution migrated their previously centralized security services out to several hosted locations, as they were a global company and wanted to improve their end users' experience using the applications without compromising any security. Due to their being a financial services company, of course, security was one of their foremost concerns. Initially, the service worked out well, but as the traffic levels grew, there were increasing levels of low bandwidth throughput and micro-freezing. We were quickly able to determine that these behaviors were happening when the systems were under load. By taking a several-hour snapshot of actual network traffic, we used the lab to duplicate the conditions. What we discovered is several issues were causing the problems. Due to the customer's general paranoia, they were sending voice traffic through the firewalls, not generally considered best practice. In addition to the firewall in question was not actually properly optimized to handle the encrypted traffic as a virtual machine. So it wasn't utilizing the full capabilities of the cloud platform. So we did have to work with the vendor so they could add that functionality into their system. So several solutions were implemented to address the performance issues. Changes were made to the configuration templates. So during the deployment, all the larger size firewalls were standardly set to be pins, i.e. no oversubscription, so there was no more resource contention within the cloud environment. Verizon also worked with the vendors in question to make sure all the vendors were able to take advantage of SRIOV networking that was available in the cloud platform. So interestingly, it was true that in one case, the vendor needed several months of development to add support for the SRIOV into their standard image. Note that no changes were needed or made to the underlying OpenStack platform itself. To further get into the weeds on this particular issue, it only affected hosted virtual firewalls. The ones deployed at the edge on our universal CP were generally unaffected for several reasons. Typically, they do not have nearly the throughput expectations that the hosted ones had. The UCP box itself doesn't even support any throughput over 1 gig. And of course, the throughput is based on the actual connection at the remote site, which is rarely anything more than about 100 meg. We saw it mostly with applications that were sensitive to latency, such as voice over IP and remote desktop type applications, where performance is affected immediately if there's a throughput issue. While it affected all the firewalls except for one, where the company had actually done the significant development work needed to optimize their application for the cloud, and it also affected all the SD-WAN vendors. Interestingly, the routers all work perfectly with no noted issues found. I suspect this more reflects the relative maturity of the networking applications and how long they've been available as virtualized solutions in the cloud, more than anything else. So in summary, our customers rely on Verizon to provide them with a reliable service. That is what telecoms stake their reputations on. So the test lab, which we built, furthers our capability to provide our customers, vendor partners, and internal teams real performance data for troubleshooting and integration testing of the various solutions. Thank you for listening to the presentation, and I hope you found it interesting and enlightening. I am not seeing any questions. I need to get on the platform so I can see questions. So I do apologize for that. So one of the questions, thank you, is does pinning the VM limit the actual benefits of implementing a virtualized infrastructure? That's a great question. And to a certain extent, it does. However, you still have the optimization of that virtualization applies. So what we've done, and I didn't really talk about it here because we did it after I recorded the talk, is that what we've done is we've selectively pinned the only the functions that need it, and the ones that don't need it, we don't. So we have a mixed environment of pinned and unpinned resources. So thank you. The second question is, how do you handle SFC with SRIOV workload? And I will have to get back to you on that because I actually don't know the details of how we did that. As far as I know, there hasn't been any problem with SFC in the environment. Another question. So does pinning the VM limit the actual benefits of implementing a virtualized infrastructure? I think that's a repeat of the first question, or very similar. And the answer is it doesn't. It means that you don't have oversubscription. We haven't. So I should point out that in the virtualized environments, particularly around networking functions, the ability to oversubscribe is overrated, since most of these functions tend to be fairly steady state. So you really can't. The architectures of most of the network functions are not designed to scale up and scale down, particularly. So you don't really gain any benefit from oversubscription. It hasn't been a serious problem, and it doesn't really, unlike some of the web applications and some of the other applications that are built from the ground up to take advantage of the fact that there's variable traffic patterns. Networking traffic patterns don't lend themselves to scale up and scale down elasticity, partially because the applications themselves were not really designed for that from scratch. And that would involve, if we do get to that, it would involve rebuilding the services from scratch as microservices, containerized services, and that work is just really beginning. So thank you, that's a great question. Question 4. Yes, so how have you seen the current pandemic affect your operations and planning? So that's a great question. And the answer is, with the pandemic, it's actually, the telecoms have actually, I would say, benefited. We obviously saw the traffic patterns change radically. So as many of our customers moved their workforces to work remotely and work from home, obviously I'm, based on the background you can see, which is my living room, I'm working from home and have been working from home since March. So what we've seen is a shift in the traffic patterns to be more distributed. However, and there was some changes in how the traffic, what traffic was where. However, Verizon was able to make changes within our core networks to keep up with that traffic, and we actually saw little or no degradation in our services provided to our customers. Obviously, what we saw is a rise in VPN traffic as customers moved, had more work from home solutions. We also added, specifically added some messaging around existing services that and emphasized the capabilities for VPN and work from home. So these were existing services that we'd been already selling for a number of years, and we were able to pivot them and have our customers put them to use for their work from home workforce. In one case, we had one customer that we stood up 5 new VPN gateways for them in under 48 hours. And they were able to send 9,000 of their employees to work from home within a week. And this particular company is a medical equipment manufacturer, so obviously very important to the pandemic. And obviously our other services, we've continued apace. And for me, I've been extremely busy, so I can't say I've slowed down. So thank you for that question. So another question, how can a solution can we extend to the container world? How and to public cloud to ensure SLA and end-to-end workflows? Good question. To answer, there's 2 answers. One is networks still have to get out to the edge no matter what. So you can't move everything into the core. We are seeing that with our customers. So over the last 10 years, there's been a rush to move workloads into the cloud. And our network has obviously been optimized. We've added a number of features, the Secure Cloud Interconnect and the SDI products, which connect directly to the cloud services. And those are very popular. However, we're also seeing a reverse trend over the last, I'd say, year or two, where customers are rethinking moving everything to the cloud. So it's not that customers are moving applications out of the cloud, they're pulling them apart, containerizing these applications and moving some of them back out to the edge. So we're seeing a lot more mixed, complex networks to support these distributed applications. So more on that to come over the next couple months. We're not seeing particularly higher SLAs just by moving into the public cloud. Public clouds are not particularly known for their high SLAs. And there's been a number of epic failures over the years with them. So most customers are using the public clouds and yes, they are, but they're using multiple public clouds. So multi-cloud strategy is highly important to Verizon. That's something that we have some. We're going to be adding more ability to incorporate multiple clouds transparently and easily, because I think that's important to our customers. Also the ability to get the applications out to the edge. I mean, customers and the end users, of course, are not sitting in cloud data centers. They're out at the edge. So we're seeing increasing interest in moving out to the edge. So any additional questions? Yes. 1 minute left. Okay. So thank you, everybody. Excellent questions. I hope you enjoyed the presentation and learned something about the importance of testing to make sure networks really work.
Thank you, Beth. And if anybody wants to see Beth's presentation and the Q&A segment on demand, please do so. And I'm sure Beth will check the chat throughout the day to answer any questions.